Ever wondered why the moon doesn't pull your house or the water in your tub? Well, it all starts with a cosmic dance of gravity. You see, the moon, though much smaller than Earth, exerts a gravitational force on our planet and its oceans. This force is at its strongest on the side of Earth, directly facing the moon, and weakest on the opposing side. This gravitational pull from our lunar neighbor is responsible for the bulge of water on Earth's surface, pointing towards the moon. It's a fascinating phenomenon known as the tidal bulge, and it's the reason we see high tides along our coastlines. Yet as Earth spins on its axis, different parts of our planet come under the moon's gravitational influence, giving us a cycle of 2 high tides and 2 low tides approximately every 24 hours and 50 minutes. But what about waves, you may ask? Well, as the tides interact with the ocean floor and coastline, they generate waves. These waves, much like rhythmic dancers, propagate across the ocean's surface, creating the soothing ebb and flow we all know and love. Now, you might be wondering, if the moon's gravity can pull on our vast oceans, why doesn't it yank your house off its foundation or make the water in your tub slosh around? The answer lies in the fact that gravity's force diminishes rapidly with distance. So while the moon's pull is significantly influential on the oceans, it's much weaker at the surface of the Earth. And don't worry about your house or the land it sits on. They're held firmly in place by Earth's own gravitational force, which is far stronger than the moon's pull at the Earth's surface. So the moon does pull on everything on Earth, but its pull is strongest on the oceans. It's this intricate balance of gravitational forces that choreographs the natural rhythms of our world. Stay tuned for more on this cosmic ballet in our next scene. Ever noticed how the sea level rises and falls throughout the day? That's the moon's doing. It's not magic or a trick of the eye. It's a cosmic dance between the Earth and its lunar companion, the moon, choreographed by the invisible strings of gravity. Now, let's delve into how this fascinating phenomenon, known as the tidal bulge, comes to be. The moon's gravitational pull doesn't affect all parts of the Earth equally. It's strongest on the side of Earth facing the moon, and weakest on the opposite side. This difference in gravitational pull causes the water on Earth's surface to bulge towards the moon. Imagine the Earth as a giant water balloon. When you squeeze one side, the other side bulges out. The moon's gravitational pull essentially squeezes the Earth, causing the water on the Earth's surface to bulge out towards the moon. This bulge of water is what we call the tidal bulge. But wait, there's a twist. There isn't just one tidal bulge. There are 2. That's right. While one bulge forms on the side of Earth facing the moon due to its gravitational pull, another bulge forms on the opposite side. This happens because the Earth, being closer to the moon, is pulled more strongly than the water on the far side. This leads to a second bulge on the side of the Earth furthest from the moon. These bulges, constantly shifting and moving with the Earth's rotation and the moon's orbit, result in the high tides we experience along our coastlines. When your part of the world faces one of these bulges, you get a high tide. As the Earth rotates and that bulge moves away, the tide recedes and it's low tide. So the next time you're at the beach and you see the tide coming in or going out, remember it's all thanks to the moon and the gravitational ballet it's performing with our Earth. Through this process, the moon indirectly controls the rhythm of our oceans. But the moon doesn't stop at creating high tides. It plays a crucial role in a phenomenon we call the tidal cycle. This cycle, with its rhythmic ebb and flow, is a direct result of the moon's gravitational pull and the Earth's rotation. Now, let's dive a bit deeper into the tidal cycle. The Earth spins on its axis once every 24 hours, but the moon only orbits the Earth once every 27 days or so. The interplay of these two movements results in the moon's gravitational pull being experienced differently in various parts of the Earth at different times. As the Earth spins, the part of our planet facing the moon experiences a stronger gravitational pull, causing the water to bulge outwards and create a high tide. This is the first of the 2 high tides that occur each day. Meanwhile, on the opposite side of the Earth, farthest from the moon, the gravitational pull is weakest. However, because the Earth's own gravitational force is also weaker here due to the Earth's rotation, the ocean water bulges outwards, creating another high tide. This is why we have 2 high tides each day, not just one. At the same time, in regions of the Earth at right angles to the line between the Earth and the Moon, the water is drawn slightly less towards the Moon, resulting in a low tide. This happens twice a day as well, giving us 2 low tides. Now, here's something to remember. It's not a perfect cycle. Because the Moon is also moving as the Earth spins, the tidal cycle is actually about 24 hours and 50 minutes long, not exactly 24 hours. This means that the times for high tides and low tides shift slightly each day. So, the dance between the Earth's rotation and the Moon's gravitational pull brings about this daily rhythm of tides. The ebb and flow that beachgoers love, that surfers ride, and that coastal creatures rely on for survival. And that's how we end up with 2 high tides and 2 low tides each day. But what about waves? Does the Moon have anything to do with them? Well, the answer is a resounding yes. When we think of waves, we often picture the rhythmic rolling of water along our coastlines. But have you ever stopped to wonder what causes these waves? Turns out tides, influenced by the Moon's gravitational pull, play a significant role in wave generation. Now let's break this down. Imagine the ocean. It's vast, it's deep, and it's in constant motion. As we've learned, the Moon's gravitational pull creates tides, these giant bulges of water that move around our planet. But as these tidal bulges travel, they don't do so in a complete vacuum. They interact with the ocean floor and the coastline. Think of it like this. As the bulge or high tide moves across the ocean, it encounters resistance from the sea floor. This resistance slows down the base of the tidal bulge while the top part continues to move at its original speed. This difference in speed causes the water to topple over, creating a wave. Now these waves don't just fizzle out. They propagate or spread out across the surface of the ocean. That's why we see waves not just at high tide, but all the time. The energy from the tidal bulge is transferred into these waves, which then move across the ocean's surface until they eventually break along a shoreline. So, in a nutshell, tides generate waves, and these waves are a constant reminder of the Moon's influence on our oceans. Even when the Moon is not in sight, its gravitational pull is at work, shaping the movement of the ocean and creating the rhythmic, rolling waves we see and love. So, the Moon's gravity also plays a role in the creation of ocean waves. So if the Moon's gravity affects the oceans, why doesn't it pull our houses or the water in our tubs? An intriguing question, isn't it? Well, it's all about the delicate dance of distance and force. You see, gravity's strength diminishes rapidly as you move away from the source. So, while the Moon's gravitational pull is strong enough to sway the vast oceans, creating the tidal bulge and the rhythmic ebb and flow of tides, it's not quite potent enough to affect the solid objects on Earth's surface. The water in your bathtub, the house you reside in, they're all safe and sound, thanks to the rapidly diminishing force of gravity with distance. The Moon's pull on these objects is so minuscule, it's virtually non-existent. So while the Moon's gravity is powerful, it's not omnipotent. In other words, the Moon's pull isn't quite strong enough to move your house or empty your tub. So, what have we learned about the Moon's gravitational pull? We've uncovered that the Moon's gravity exerts a force on Earth, particularly its oceans. This force is strongest on the Earth's side facing the Moon, resulting in a tidal bulge and the high tides we observe along coastlines. As Earth rotates, different regions experience the Moon's gravitational pull, leading to the rhythmic cycle of 2 high tides and 2 low tides approximately every 24 hours and 50 minutes. This tidal movement generates waves, creating the familiar oceanic motion we see. Yet the Moon's gravity is not all-powerful. It doesn't have the strength to pull objects like houses or even the water in our tubs. The solid parts of Earth are held stable by Earth's own gravity, far stronger than the Moon's pull at the Earth's surface. So while the Moon may not be able to pull your house or the water in your tub, its gravitational pull plays a crucial role in shaping the rhythms of our world.